Okay, this is the continuation of lab number 2, building a two-tier VLT fabric using the Dell demos website. And I already configured each of the switches. I already configured the two leaves for switch 1 and switch 2, and the two VLT spines, switch 3, spine 1, switch 4, spine 2. And this is what they mean by a two-tier VLT fabric, meaning that you're gonna have a top tier, which is gonna be this tier right here, that is gonna have the SVIs. It's gonna have the IP addresses on the VLANs, and then you're gonna have a pair of leaves that normally these two leaves is gonna go into perhaps rack 1 in this example. You might have another set of leaves for rack 2, another set of leaves for rack 3, rack 4, and so on and so forth, as long as you still have enough ports on the spines, right, to support all that many racks. Let's go ahead, explain a little bit about these OS 10 virtual appliances from Dell. So basically, these virtual appliances are based on the Dell S5248 switch. That is a switch that has 48 ports of 25 gig, and this is how it looks like, the S5248. So each of these 48 ports can run at 1, 10, and 25 gigabits per second. Then we're gonna have a couple ports right here, and these two ports right here will run at basically 2 by 100 gigabit, 2 by 100 gigabit, and these ports can be broken into 425s or 410 gigabits, or they can be broken into I think it's 8 by 25, or they can be used like I like to do for the VLT. So we can use these two ports for VLT, so that way we can have a fast pipe going from leaf 1 to leaf 2, from spine 1 to spine 2, just in case there is a failure from one of the uplinks. Then you're gonna be able to pass traffic through this VLT in that situation. And whenever there is no failure, there is some broadcast traffic that goes across that line. So you want to have a good pipe going from leaf to leaf and spine to spine. Then you have 4 ports of 100. These ports of 4 ports of 100 can be used to uplink from leaves to spines, for example. In this case, all the switches I'm using are S5248s. So yeah, there is a way to make it happen. So let's go back here. And so the first thing I wanted to show you is that these virtual machines with OS 10 virtual, they're based on the 5248, right? Of course, this is the virtual. I just show you how the hardware looks like and the description for the ports. So let's go ahead and another thing I already kind of mentioned is that each Dell OS 10 switch or virtual appliance has a safe configuration that can be loaded, like I explained on the previous video, and I already apply that. I copy that file and apply it to the running configuration. And so let's see what happened after I did that to each of the switches, because we kind of loaded that safe configuration, so that way I didn't have to type anything. I just let it run. I'm looking for switch 1. So let's take a look at switch 1. So let's go ahead and do show running config. And so let's take a look at this running config. Okay, so if you take a look over here, let me see where the command starts. And just keep in mind that I'm trying to make this as casual as possible. I'm doing this in one take, so it's not gonna be perfect, but I'm gonna try to make it as as interesting as possible. So whenever you run this configuration, it shows that the version for the operating system on this OS 10 virtual appliances is the 10.5.1.0. I think the latest version as of today, July 16, 2022, I think is around 10.5.4 if I'm not mistaken. And so that way you have an idea, and then it gives you an option to do a virtual what is it called, routing forwarding. So that way you can partition the switch, and instead of having a single switch that can do layer 2 and layer 3, basically layer 3, right, you can partition the switch, and once you partition this switch, you can have multiple switches, right, each one with its own forwarding table, but that is a topic for another day. If you look over here, it has the host name, which is OS 10, switch 1, which is leaf 1, and rack 1, for example. And let's see what else we can see. It has the type of password, right, that you can secure, so that way people cannot crack it. It has a high level of security. If we keep on going down the road, you're gonna notice that and this is what threw me off the first time I saw this type of layout, which it makes sense now. So you're gonna have what is called port groups, port group 1. So port group 1 is basically the first 4 ports of 25 gig that can also run at 10 or 1. So once you set the speed, in this case to 25 gig, all 4 ports in group 1 need to be at 25. If you set the speed to 10 gig, then all the 4 ports in port group 1 need to be running at 10 gig. So for example, if you look at the switch right here, you're going to see that you have port 1, port 2, port 3, port 4. So basically all these 4 ports need to run at 25 gig as configured, right? If you do this at 4 by 10, then all these 4 ports must run at 10 gig, all 4. Okay, so just be careful whenever you're planning, so that way you keep that in mind, right? Let's see what else. So basically you're gonna have 12 port groups. Let's double check that. So if I keep on scrolling down, you're gonna see that we're gonna get all the way to port group number 12. Okay, and port group number 12 is gonna be the last port, which is gonna be let's see here, this port group right here. This is gonna be port group 12. This is gonna be port group 1, port group 2, port group 3, and so on and so forth. So basically all the 48 ports are gonna have the 12 port groups, right, in sets of 4. Now for these 2 100 gigabit dual density ports, for those we're gonna be using, as you can see here, right now they're running at 2 by 100, but if you want to break it into 425, so some other speed, then once you do that change, it's going to be reflected over here in port 13 and port 14. Port group, remember, port group 13 and 14. What about the other 4 ports left? So port group 13 is gonna, port group 15 is just a single 100. Port group 16 is a single 100. 17 and 18 also are a single 100s. Now, if you change the speed because you want to use a breakout cable, then over here it's going to reflect perhaps 4 by 25, just to give you an idea, or 4 by 10. So it's a multi-rate. These ports are multi-rate, so you can change the speed. You can use breakout cables, copper or fiber. Now let's keep on going down just to get familiar with the running config. So over here, the file that I run, that is on each of these virtual appliances, already configured the VLANs for this lab. In this case, VLAN is by default. VLAN 200 was added, and because this is a leaf, we don't have an IP address on switch 1 because it's leaf 1 in rack 1. But if we take a look at the spine for, I will say, spine 1, which is going to be switch 03, So let's look for that one. That's switch 02. That's switch 03. So if we look at switch 03, let's go ahead and do a show run. And let's go here. It's showing us all the port groups like I showed you before. So let's keep on going down. And then over here, you're going to have the SVI, right? The switch version, I'm sorry, the switch virtual interface. Let me see here. So over here is going to be the IP address for VLAN 200. And just keep in mind that if I'm, for example, giving you the description for an acronym, and if I perhaps I messed up in one of the letters on an acronym, just bear with me. I'll make sure I make notes once I review the transcript, and just in case if I make a freedom slip, I can go back and correct it. But yeah, the switch virtual interface is going to be the one that is going to be terminated in switch number 3, VLAN 200, and this is the IP address. If you go to switch number 4, which is spine 2, this IP address is going to be 10.1.1.253, just to give you an idea. And the VRRP group, which is the virtual redundancy routing protocol, that one is going to have a virtual IP address. So you're going to have in switch 3 252, you're going to have in switch 4 253, and the virtual IP address for VLAN 200 to go into the virtual redundancy routing protocol, just in case you need to go to a layer 3 network. It's going to hit this IP address, which is it's great. Then you're going to see that we have port channel 10, and all this information was loaded by the file that I copied into the running configuration. So it kind of configured everything for me, and it was pretty fast. So let's continue exploring switch 1, leaf 1 in rack 1. So if we keep on going down, you're going to see that it configured the port channel 10 with as a trunk, allowing VLAN 1 and VLAN 200. So let's identify that port channel 10 in switch 01. So this is switch 01 right here, and then this is the port channel 10 that we're looking at right now. Now let's look at the port. I think it's port 30. So let's go back to switch 01, and let's see here. Okay, switch 01. Okay, let's keep in port channel 30. Let me move this around. You're gonna see it. You're gonna see it over here. So that's port channel 10 and port channel 30 going down, and the same thing. We're doing it as trunk. VLAN 1, allow VLAN 200, and we're gonna tag this one. We're gonna tag it as a VLT port channel 30. Okay. So it's part of that VLT domain. So let's see what else. Then the interface management IP address. And if we keep on scrolling down, we're going to see that the first Ethernet port 111 that is part of, remember, port group 1, as well as port interface 112 and 113 and 114. Those are going to be part of the port group 1. Let's take a look at something here. So interface 1 and 2 are no switch port, like I explained on the VLT video with a single VLT fabric. And so basically 1 and 2, those are in no switch port, because the VLT process is gonna create a special port channel 1000. And then you have port 3 that is part of port channel 10, and it's telling you that interface number 3 is part of port channel 10, and also interface 4 is part of port channel 10. So let's keep scrolling down, and then you're going to see that interface interface number 5 is going to be to port channel 30, and then this port is already part of that channel 30. And let's scroll down. All the other ports are not being used because we're using only a few ports for this exercise. But over here you get the idea. You're gonna see all the ports. There's a way that you can compress this. I just haven't used that feature that often. So let's go here and okay. So at the end of the running configuration, you're gonna see the information for the VLT domain, and then on the VLT domain is gonna show the backup destination, which is gonna be switch 02, and then the discovery interfaces 111 and 112, like I explained before in the other video. And then the virtual MAC address is the one that we created, 0A, 0B, 0C, double D, double E, double F. And that will complete this block. Let's go and let's go ahead and see what else we have here. And let's look at some of these. Oh, I wanted to show you like the show command. Once you type the show, do shift question mark, and then it's gonna give you all the options that we can use, right? All these modes of operation. So let's just explore some of them just to give you like a little tour. So let's take a look at the show boot. And on the show boot, you're gonna see that we have on this particular OS 10 virtual 10.5.10 in partition A, and another copy in partition B. The one in partition A is active. The one in partition B is a standby. Okay, so let's now that we show the boot, let's show the version. So let's do show version, and the version is going to be 10.5.1.0, and the build version is the .124, and it tells you that this is the system S5248F virtual machine based on an Intel x86. So let's go into configuration mode and just type, it's like configure terminal in Cisco. In Cisco you do configure terminal. Over here we do config. I just wanna do, and you can do terminal as well, right? Let me exit, or you can just do like config and then hit the tab key in your keyboard, and then just with configure, and then you're there. You don't have to type configure T. So once you're in config, then shift question mark, and then it's gonna show you all the options, right? You can go, for example, interface, Ethernet, and then you can type like for example 1.1.1, right? And then you can, let me see, show, you can type show configuration, and then by typing show configuration it's going to show you that in Ethernet 1.1.1 is not shut down, no switch port, because it's part of the VLT. So let's go ahead and exit and try a different interface. And what we can do here, we can use the up arrow, just like in Cisco and some other vendors. You can CLI, you can go into, instead of 1 and 2, let's go to 3 and type show configuration, and then on this particular port is no shutdown, is part of group port channel 10 active, and no switch port, just to give you an idea. So let's go ahead and exit. And if you want to go all the way to the exact mode, you just type end, and it will take you to that prompt. Let's see what else we can see. We saw the version, the configure. Let's do the environment. Let's do show environment. And then it's going to show you, for example, this particular virtual version doesn't have an NPU. It doesn't have a networking processing unit. So we're not going to be able to do configurations with spanning tree, nor ACLs, not quality of service, but we can do pretty much all the other features for layer 2. We can do the VLT, we can do uplinks, we can use most of the commands for layer 3. I mean, I will say almost all of them. So we can create really powerful scenarios and proof of concepts. Let's see what else. So that's show environment. Let's do show event. Let's see what options we have. I'm doing shift question mark. Let's do history. And these are some of the, yeah, let me do, these are some of the things that I have worked since I started the lab, and it will give you all kind of information of changes that have occurred. So let's go ahead and get Control C to get back to the prompt, and let's continue the tour. Let's do, all right. So now we got it. So that's neighbors, and then we have neighbors detail. And then what's going to happen is that it's going to show us the, in this case, interface Ethernet 111 on this leaf 1 is gonna see switch number 2, which is the leaf number 2, right? And so basically is this LLDP is working, is identifying the neighbor going out Ethernet 111 on switch 1, and on interface 2 of this switch 1 we should be able to see the same neighbor, right? Because interface 1 and 2 are going to leaf 2, which is switch 2 right here. So that is working. LLDP is working. So let's see what's happening in the other interface, which is 113. So 113 is going to switch number 3. Okay, so that's going to be going to switch number 3, which is switch 1 is interface 3 is going to switch 3, and it's right there, and that's switch 3. And I think there is one more interface. So this is Ethernet 114, which is this one right here, and that one is going to, it should be to switch number 4. So let's keep on going. Let's see here, Ethernet 114 going to switch number 4. There you go. And just keep in mind that, yeah, this is the first time I'm showing all this. I'm going off the rails on this one. Actually, I'm going off a script, and that's why you're gonna see this. But that is helping everybody. At least you get an idea, that sometimes you have to be patient whenever you are troubleshooting something. Okay, so in this case, yeah, this is switch number 4, and LLDP is working. So let's do Control C. Go ahead and verify the port channel, MAC address, and interface index. So let's go to switch 1. In this case, it's going to be switch 1. And then we're going to look for switch number 2. Let me see if I can find switch number 2. There you go, switch number 2. So what I'm going to do here, I'm going to drag this show VLT1 VLT port detail, okay, just to check on these top of rack switches, right? Leaf 1 and leaf 2. We're going to check the port detail. And then let's do the same on the second switch. So let's drag this command. And now what we're looking at here is showing VLT port detail. In this case, it's going to be port channel 30, which is the one going down to the server, port channel 30. Let's go back to that switch. Okay, and then on switch number 2, which is Lab2b, is showing us that is recognizing VLT port channel ID 30. If we take a look at switch 1, is you see this asterisk right here, right? And then that's switch 1, and then for switch 2 the VLT unit ID is 2. On switch 1 is VLT unit ID 1, for example. So let's move on to the next one. It says verify, check the port channel MAC address and interface index on switch 1 and switch 5. Please run the following commands on switch 1 and switch 2 and switch 5, okay? Because those switches are involved here: switch 1, switch 2, and switch 3, which is mimicking the server, right? So if we take a look at show interface port channel 30, you're gonna see that the MTU is set at 1500 bytes. We can change that. We can do jumbo frames. If we check switch number 2, Lab2b, the MTU is 1500. The index that they want us to check is 78, which is the same index for switch 1. This is the index for switch 2. And now we're gonna check the index for switch 5. But before we do anything, I think on this one I'm gonna have to log in, admin, and then once we go into exec mode, let's go ahead and drop that command. So this is gonna be the switch that is mimicking the server, dual homed, and we have the same MTU, so we are good to go. Then we're gonna have let's see what else. The index is 78, and this is really something that I wanted to show you. So basically this is switch 1. The line speed for switch 1 going to the server, that link is a 25 gigabit link, which is gonna be, I don't want to go back, but you get the idea. So if I go to switch number 2, the line speed going to that server is a 25 gig as well, right? And switch number 5, which is the server, right? The server representation is a 50. It's actually aggregating the bandwidth. 25 plus 25, that is basically a 50 gigabit per second link. So these two ports right here are lagged, and you got 25 and 25. That's a 50 gigabit per second pipe. So let's see what else they want us to do here on this lab. It says let's go ahead and verify the VLT status in switch 1, switch 2, and 3 and 4. So let's go ahead and do that. And let's go to switch. This is switch 2. This is switch 1. Let's go do Control C to get to command prompt, and then let's run this command, show VLT1. Let's drag it here, enter. Now let's take a look at over here, enter. So let's take a look, because this is part of what I'm gonna do next. I'm gonna go ahead and bring down one of the switches. So if you look at the switch 1, Lab1, rack 1, for example, the one connected to the server, switch 1 is the primary. The role of this switch is the primary in the VLT domain. Okay, VLT domain 1. The second switch, which is switch number 2, it's gonna be let me see here. It's gonna be secondary. That's gonna be the role for the second switch. The unit ID for this switch right here is gonna be 1. The unit ID for the other switch, which is switch number 2, is unit ID 2. Now let's take a look at the role priority. Whenever you have the role priority the same, right? Normally the switch with the lower MAC gets the primary role, right, by election. But I already failed this switch, so this switch right here, let me see, it has a lower MAC, so it's 0C 11 BA 9. So this MAC address is higher by one. Well, it's higher because it's 9 and this one is 8B, right? So these digits are the same in both switches, 0C 11 BA. But over here, the 8B, it is a hexadecimal. 8B is lower than 9D. So this switch was the primary before, because both priority roles are the same, right? So because I already failed this switch, the other is the primary. So once we failed switch number 1, then we're gonna take a look and see to make sure that this one becomes primary. So that's part of the scenario that we're gonna do. And I guess that's it for now. What else? These roles can be changed, so that way you can set one, but we're gonna leave it just by default. So let's see what else. It says here, check the VLTI link status. Okay, so the status is up. VLT per unit ID version, so that the peer is unit 2, which is this other switch right here, and then the VLT peer unit for switch 2 is going to be switch 1, which is this unit ID right here, right? Let's see what else. The role, yeah, we talk about primary and secondary, and that this is supposed to be the primary because the role priorities are the same. I already failed it. We're gonna fail it back. And the unit ID, we already talked about. This is unit. So one thing we're gonna do here, these PCs that I have here, PC1, PC2, PC3, and PC4. So PC1, 3, and 4 are in VLAN 1. PC2 is in VLAN 200. So I should be able to ping from PC1 all the way to PC3 and PC4. I should not be able to ping PC2. So let's test that. Let's go to PC1 here, and let's do ping, and then let's do the IP address for PC3 is 10.1.1.3. That's the IP address for PC3 that is up here, and that is connected to spine 1. So let's hit it. And the reason why we're able to ping it is because it's in VLAN 1, and that VLAN 1 is being allowed on the port channels, and all the port channels, as well as VLAN 200. They're allowed in all the port channels, including the VLT special port channel 1000s. Let's see what else. Let's ping this other one, PC4, which is gonna be, well, PC4. We just ping PC3, and we should not be able to ping PC2, and the reason why is because PC2 is in VLAN 200. So let's type PC2, and that's not reachable. All right, so the next thing we're gonna do here on this practice, I'm gonna go ahead and place packet capture on the 4 links going from the leaves to the VLT spines. So I'm doing this part right here. But before I do that, I need to place PC1, PC3, and PC4 in VLAN 200. So let's do that. Let's go into this server, which is actually a switch. let's go ahead and go to switch number 5 and place port 8 in VLAN 200, okay, in order for PC1 to belong to VLAN 200. I'm gonna have fun listening to the reading the transcript. Okay, so let's go to switch number 5, which is this one right here. All right, so let's do Control C. Right now it's 1:29 a.m. So let's do configure, and then it's gonna be interface Ethernet. Let me see. Let's see. That's shift question mark. Okay, so now I can do the 118, and then let's do show config, and the configuration right now is not shut down. It's part of VLAN 1, but we need to move this one to VLAN 200. So let's type switch port VLAN access VLAN 200. Let's type show config, and now this port number 8 is part of VLAN 200. So basically this PC1 now is part of VLAN 200, which is nice. All right, so let's go ahead and exit. I'm gonna or end, and I'm gonna do write memory. Okay, so that's good. So now let's go to PC3. So we're gonna go to switch number 3, interface 9, and set it up in VLAN 200. Okay, so let's go to switch number 3. Let me right here, and then we're gonna go to Control C, C as Charlie, to get to command prompt. We're gonna go into configure, interface Ethernet. It's gonna be 1. Okay, what is it? 1, and then it's gonna be 9, and then let's do show config, and then right now it's in VLAN 1, so that's why we were able to ping it from PC1 to PC3. So now let's put this sucker into switch port wavelength, switch port let's see, yeah, it's been a lot. It's already. I'm getting tired. Switch port access. Yeah, I need to do this earlier. Switch port access. It's gonna be VLAN. Okay, 200. And then let's show config. And okay, right now it's in VLAN 200. Let's type do write mem. That's another way to do it. Let's do end to go all the way to command prompt, and we're done with this one. Now let's go to the next switch and place PC4 in VLAN 200. So we're gonna go to switch 4, interface 9, and place that sucker in VLAN 200. So let's go to switch number 4, which is this one right here, and let's go ahead and log in admin. There's a way that you can extend the time that it takes to kick you out. You just have to go to, I think it's exec. Well, I don't want to get into that right now, but there's a way. Let's go to configure. Yeah, what the heck. Let's go to exec timeout. And then okay, so you just put no exec timeout. Okay, that's it. All right, I don't want to deviate from this. I don't want. Okay, so let's concentrate. Let's concentrate. Let's go to the interface 9, interface Ethernet 119, and do show config. And that one was also in VLAN 1. Let's double check something to make sure that we are on track. Yeah, VLAN 9 in PC. Okay, VLAN 9 and switch 4 need to be placed into VLAN 200. So let's do switch port access VLAN 200. Let's do show config, and then we can see that we have it in VLAN 200, which is great. Okay, so now let's do let's do end, and then let's try write mem. There is different ways that you can do write memory. Well, let's try ping 4 PC4. Now I'm getting. Yeah, just keep in mind this is an emulator, so that is well, if I'm doing a ping from PC2 to PC4, which is the echo ping request. Now I'm getting the reply over here, 114 replying to destination 112. So that's the ping reply, the ping request. So that's working. Okay, so that's good. Now I just wonder what link this is. This is okay. So the switch 4 to switch 2. Switch 4 to switch 2, 113. Okay, okay. I know which one it is. So basically that ping is going from switch 2 to switch 4 via link 3. So that's what you see here. 113 switch 4 and 113 switch 2, and that's where the ping is going. All right. Yeah, it's just, yeah, sometimes whenever you're working on GNS3, sometimes you're gonna have to start the console again. So I'm just gonna check what is the VLT status on this one. So let's go show VLT 1. This one is still the primary because I shut down switch 2 instead of 1, but that's fine. Yeah, this is gonna be the last one, guys. I'm just gonna, I cannot start the console on that one because it's off. Of course, it's offline. So let's just start that one and wait until it boots. Yeah, we're about to finish this one. Yeah, just keep in mind that I'm just showing you some of the functionality and commands and scenarios, and I'm going off a script. Actually, I'm going off a script on this one. So let's do admin. All right, so let's go back here. And let's wait for this thing to load. And we're about to finish. So yeah, that Warshark, it has to do also with that this is GNS3 environment. And next time I'm gonna try to do maybe a couple of um, packet points instead of 4, because on this virtual environment, yeah, it's a little bit cumbersome to analyze them all for. But yeah, I think I'm gonna give it another shot. I'm just waiting for this thing to load. All right, so this is switch 2 that we are. I actually turn it on again. Now, if you had to reload this switch, in GNS3 you had to shut it down and turn it on. That the reload is not gonna work. It has to do with the code. Keep in mind this is an emulator. Let's see what else. So let's do show VLT1, and this is the secondary. So let's go ahead and shut this one down and see what happens. So let's go back here And now that I have two, it's a lot easier. Just a lot easier. Yeah, let's take a look. All right, so let's go back here. So let's do. Now is the primary. And yeah, this session kind of hang. Oh no, it didn't hang. The switch is down. That's why we don't have any connectivity. So now that the switch one is down, it's inactive. That's why we couldn't log into the console. Okay, so this is good. So that was the primary, right? And now this sucker, which is switch 2, now is a primary because the other one is down. Now what I'm gonna do here, I'm gonna go ahead and turn this one on. And let's just check side by side. So the other one should be the secondary once it comes back alive. VLT1. Right now it's at 2 o'clock in the morning. Yeah, that's fine. But I love this. I had to share this, you know. A lot of people, they're not aware. You know, I haven't seen that many videos of people actually building stuff with OS 10 online. I'm going to keep on looking because I want to learn from others, you know. Let's see here. Oh, okay. So now the role is secondary. Look at that. So that part is working. Um, let's go ahead and do this packet capture again. You know, I don't want to give up on this. Let's go ahead and do stop the capture. Let me think about this then. Yeah, we're gonna keep it simple. Let's shut down one again. And let's go ahead and do a packet capture here. And a packet capture here. Yeah, let's do that. And we're about to finish. Yeah, this is gonna be. Yeah, this is interesting. Yeah, because nobody showed me this. I watched a few videos, but I just didn't know how to present it. Like using, I never used the Wireshark until yesterday. I mean on a GNS3. I mean, I just had to get familiar with it. Oh well. So let's take this over here. That's one. I have the others. I think the other ones are down. I didn't close them. Let's yeah, I need okay, take your time. So in this case it's gonna be switch 2 to switch 4. Switch 2 to switch 4 via 113 and switch 2 to switch 3 via 114. So I'm gonna get rid of this one. And I'm gonna get rid of that one. Yeah, you see that one is not running. Like this one is active and I can stop it. This one is the stale one that we had before. So let's get rid of that mother beep. Yeah, it's getting late. If I start swearing, that is getting late. So let's take this. This is okay. 113. This is 114. So let's keep it real. Let's move this over here, and let's move this over here. Now what I can do, I can go ahead and take PC. Well, let's take PC2 console. Let's make this console bigger. Let's do change settings, appearance. Let's choose 16 size for the font. Apply. Goodness. All right, so let's go ahead and open the other two screens. Yeah, this is a little bit cumbersome to navigate. Cumbersome but not impossible. All right, maybe I should add some type of commentary and or news while we wait for things. All right, so let's do ping 10.1.1.3, and right now is going to rule link 4, which makes sense, which is this link right here. So that's good. All right, so now let's ping it again. Echo reply, echo request, echo reply. That's beautiful. Yeah, you just had to play with this GNS3. Sometimes it's a little bit emotional. All right, so that's gonna be 10.1.1.4. Let's ping that mother. All right. All right, so that's ping request. Ah, okay. All right. And we have the ping reply on this other link. Okay, yeah, because so now we're getting we're going from PC2 to, so that makes sense. It's using this link right here, which is 114. That's the ping reply right there. The ping went from PC2 to PC4, PC2 the source, PC4 the destination, and then the reply came from 4 to 2, coming from this link 113. And then when we ping PC number 3, let me see here. It went through this other link 114. So that makes sense. So I'm feeling better. I had a mess before, but I think I was able to figure it out. So now we were able to test that if we bring one switch down, if this was the primary, then this other one becomes the primary for the VLT, and for the yeah. So that happens. If I switch it back, then um, this is gonna remain the primary until this one goes down, and the other one, it will pass the ball back and forth. Um, okay, so that makes sense. I don't think I have anything else on this one, and of course we can modify the MTUs. I was looking at the MTUs, and the MTUs for these ports are 1500 bytes. For some VMware NSX VXLAN, I think the packets are like a 1650 bytes. For the new Geneve protocol, I think it's 1700 bytes. If you have something smaller, it's not gonna work. For storage and some other applications, some people do jumbo frames, and we have jumbo frames on these VLT ports for now. What else can I show you? No, I guess that's it. And this is gonna wrap up this VLT technology. The next lab is gonna be about building a VLT fabric with layer 3 routing upstream using OSPF, I think. And then there is another lab that it will do a pure layer 3. And then in the advanced labs, we're gonna have a technology called EVPN that will allow us to do multi-tenancy and virtual tunnels. So that's gonna be interesting. And we're gonna also test to make sure that the traffic flows. And I do apologize if this is a long video. I just wanted to show you what you can do with GNS3. And I guess that's it. I do have a setup for GNS3 on my workstation. The reason why I'm using this Dell Lab is because things are already provisioned. These switches come with a config file that I can just drop into the running config, and I don't have to type everything. But I'm gonna find out how to do it in GNS3, so that way I have my templates in my own PC that I can use other vendor um, virtual machines as well, such as routers and some other devices to generate traffic. And yeah, so that's interesting. I think I'm gonna stop. It's being a long video.